Hello, and welcome to another segment of Geology 1 Processes and Products Lab DVD. In this segment, we will discuss shoreline processes. Geologic agents are those geological processes which modify the earth, and we've talked about how things erode, transport, and deposit. There are many geologic agents of the earth, including glacial ice and running water. Shorelines also represent a special environment because we have many different processes that operate at the shoreline, including longshore currents, we have rip currents, we have the actions of waves moving in, and tides. So there are many different processes affecting the shoreline, and sure enough, we see erosion, transportation, and deposition at the shoreline. What we will talk about today are a few of these features. We're not going to be very interested in transportation because longshore currents do transport along. We also know that wave action can erode and transport, as well as some of these rip currents. We see transportation there as well. We're going to focus instead on the erosional and depositional features of shorelines and also take a look at how we can identify those on topographic maps. Let's start with deposition. The most obvious form of deposition at the shoreline would be that of a beach. Now, beaches come in a variety of flavors. You can have pocket beaches, or you can have continuous beaches or strands. Let's look at a couple of examples of those. Here you see a beach area where you have very little isolated pieces of beach or accumulation of sand. This is kind of a rocky beach. There's not much to it. Contrast that with Florida, where you have extended long strands of beach, and we have a lot more area. Very different environments, but both are beaches, accumulation of sand right at the shoreline. Now, if we look at a profile of a beach, we can see that there is a difference between low tide level and high tide level. But as long as the beach still gets wet during some part of the day, we are looking at the foreshore of the beach. This is the area where the sand still gets wet some point during the day. The back shore of the beach is marked by berms, which are higher points of the beach. We may have some dunes if we have enough sand beyond the berms, and the back shore of the beach area stays dry except during storms. Okay, let's talk about what can happen when some of that sand located at the beach doesn't stay in its proper place. If it's picked up by longshore currents, it can be moved along the beach. If it's moved beyond the beach line where the land is, we have a free arm of the beach, or a spit. We can also see that spit migrating completely across a small opening or a bay, and in that case we would have a bay mouth bar. Let's take a look. Here we see a beach area, nice sandy beach, and we see migration of the sand beyond this nice little bay here to where the sand has moved into open water. This area where the sand's moving into open water is referred to as a spit. Now, in which direction do the longshore currents flow? Since the sand is moving in this direction, as evidenced by the spit jutting out, we know that the longshore currents also follow the land from the left to the right in this diagram. Now, if this sand would migrate and be added to so that sand would close off this little bay, this would be known as a bay mouth bar. Here is an example of a spit outlined in yellow. You can see the sand jutting out into open waters. What's the direction of the longshore current? Well, since the sand is moved beyond the beach, the longshore current here must at least move in this direction because the sand is being carried in this direction. Sometimes we can have longshore currents coming together or coalescing. When currents come together, and we can end up with sand that will actually move from the mainland, from the beach, out to an island. Usually what happens is we have a current from this direction, another current from this direction, and the sand is carried out from the beach to either an island or another piece of land. We call that feature a tombolo, Tombolo, and it connects an island or a rock to the mainland. Here you see we have mainland here. This is a beach, and we have a nice little island or rock jutting out here, and sand has been moved from the beach on either side out to this island. So this would be a tombolo. Probably what's going on in the way of longshore currents, we have currents moving from this direction as well as this direction, and we get the accumulation of sand out to the island. We can also see barrier islands forming that are parallel. They're low islands parallel to the shoreline. Barrier islands form in a variety of ways, actually, but they can be distinguished on topographic maps simply because you see a long, narrow island that's running parallel to the shoreline. Here we see an overhead map, and this entire structure would be Barrier Island. Notice that barrier islands do migrate. Here we have the outline of the island back in 1849 when it was surveyed, and now we see the position of the island outlined here in yellow. So this island has actually migrated toward the continent. In addition to depositional features that we find along shorelines, we also know that waves and longshore currents can erode as well and produce some features that are pretty characteristic of shorelines in both emergent and submergent coastlines. We can see wave-cut cliffs. This is the land on the face of the continent as it meets the water, and as the wave action continually hits up against that land, we're eroding away, and the cliff will slowly retreat as the waves continue to erode it. So over time, we'll have a retreating cliff line toward the land as more and more erosion takes place, and we also are eroding the bottom part of a terrace, a marine terrace. And that's probably best seen in a diagram. Here we have wave action, and let's say originally this is our profile of our continent. Well, over time we have erosion, and we end up with a flat surface which is seaward of the land. This is called a wave-cut platform or a marine terrace. And now we have a cliff. As erosion continues, that cliff is going to retreat toward the land, and our platform will widen. We can also see remnants of rock that's more resistant in the forms of caves, in the form of sea arches or stacks. And as the resistant rock is eroded away in certain areas, we get sea caves. Here you see a sea arch in Wales. Again, wave action erodes away. We have a nice little arch. When arches fall or we end up with little bitty remnants of rock, we call those stacks. Here are some examples of sea stacks at the Faroe Islands. Now, shoreline erosion is not necessarily a good thing. For example, in the U.S., Louisiana has the greatest amount of coastal erosion than any other place in the nation and is continuously losing a lot of land each year. So what can we do to prevent shoreline erosion? There are a couple of solutions that we're going to talk about. There are many other ones, but we'll focus on some of the more common ones. For example, jetties. Jetties are long walls that extend from the shore that protect the harbor entrance, and they actually help to protect against further erosion between the jetty wall and the land away from the harbor entrance. Seawalls are a very expensive way to protect the shoreline, but they can be effective, and in some cases and in some places they may be the perfect solution. Groins are barriers that are perpendicular to the beach, and we're going to see how those work in just a few slides. This location is Galveston Island, Texas. Galveston was hit by a huge hurricane in 1900. This was before we even named our hurricane systems, and the entire island was decimated. And as a result, the people of Galveston decided to build a huge seawall. This is part of it today, and it does protect against shoreline erosion as well as offers some protection for hurricanes. These are groins. These are perpendicular barriers that jut out from the beach. Now, how do these work to prevent shoreline erosion? Well, as the longshore currents move the sand along the beach, the groins will actually trap the sand and prevent the sand from being moved completely away from that beach area. So based on that concept, from which direction is the longshore current flowing? Is it coming from here, from the north to the south? Or is it coming from the south to the north? I think you can see that we're accumulating sand on the southern side of each of these groins, and therefore the longshore currents are flowing from the south to the north. And as they pick up sand, the groin traps the sand, and it can't be carried further and further away from the beach. Groins. Let's look at different types of coastlines. We have either a submergent coast or an emergent coast. In a submergent coast, the land level is moving down relative to the water, the sea. So we have an original land mass, and in a submergent coast, either the sea level is rising or the land level is actually subsiding. Either way, we're looking at a drowned coastline. The opposite of that is an emergent coastline, where we have a body of land and either the sea level is dropping or we have rebound or uplift and the land is rising. So submergent, the land is moving lower relative to the sea, and emergent, the land is moving up relative to the sea. Let's look at some of the characteristics of each of these. In a submergent type of coast, again, this is a drowned coastline because the water's moving up with respect to the land. We often see estuaries, and these are drowned river valleys. They're pretty obvious on topo maps, and we'll see an example of that later on in this segment. Here is a picture of an estuary. You can see that we are at a submergent coastline. It looks like land level is rising. It looks like we have a lot of erosion in this area. And here is an example in the next slide of the South Louisiana marshes. Again, this is a submergent coastline. The coast or the land is moving down with respect to the sea level. An emergent coastline, on the other hand, remember, is moving up, or the sea level is falling with respect to land. Here we're going to see wave-cut cliffs and platforms, and we may also see some exposed marine terraces. This is an emergent coastline. Notice we have wave-cut cliffs here. The land is moving up. And this is a great photograph. Note that we have a series of these steps. This can be common in an emergent coastline. What's going on here is that as the wave action is carving out that nice flat wave-cut platform, we're also seeing a rise in the land with respect to sea level. So now those wave-cut platforms or marine terraces are going to be exposed. So here we have a former wave-cut platform. This used to be under the water. And as the land rose or the sea level dropped, it's exposed. And then this one is being created, again, as sea level drops or the land's rising, or a combination of both. We see this marine terrace exposed. So, how do we approach a topographic map? Well, here are some tips. Shorelines are easy to spot. Just look for the water. Emergent coasts may have those former marine terraces, the series of steps that we just saw in that photograph. A submergent coast will have estuaries. We also looked at directions of longshore currents because of spits. So let's take a look at an example and see if we can pick out few features at least on this map. We know we have a shoreline. We have water and we have land. Look at this feature. You can see that we have beaches here, but we seem to have some sand movement beyond the main beach, continuing to move all the way here. What would this feature be called? Since the sand has been moved beyond the beach, this would be a spit. If this were formerly a bay, and I don't think it was, but if it were, this would be a bay mouth bar at this point. Okay? Now, what direction is the longshore current flowing? Well, since the sand has been moved beyond the beach in this direction, we know our longshore current is also flowing in this direction. There's some smaller features over here, and they probably just look like dots to you, but they are labeled as rocks. These are probably sea stacks. Now, what is this feature? You may remember from the photograph, this looks an awful lot like a drowned river valley, and it is. It is an estuary. So, if you had to look at the estuary, we do see some sand moving beyond, but we don't see any evidence of stepped contour platforms or marine terraces. What kind of coastline would you suspect this would be? If you guess submergent, you're probably right. That would be my guess as well. This concludes our section on shorelines and coastal processes. If you have any questions about topographic maps and shorelines, or any questions about any of the shoreline processes, please feel free to email your instructor. He or she will be happy to help you and answer your questions. Thank you very much for joining me, and have a good day.